Welcome to the final video in the series. This covers the last 5 days of 30 Days Lost in Space. In these 5 lessons, we're going to be putting together everything we've learned so far. And it's going to involve the following components. The hero board, of course, both displays, the 7-segment display and the OLED display, the keyboard, rotary encoder, LED, and the little dual inline package switch, and a few resistors. So thank you for staying with the series so far, and let's jump straight into day 26. Here's the circuit, a very complicated circuit, that we're going to use for the next 5 days to finish up the course. So in fact, in this day 26, we're not going to use most of this circuit, but it's all pre-wired up, and it looks like we're going to be expanding upon it day by day. So onto the hero board, we have the keyboard wired up into 8 pins here. We have an LED wired up, grounded with a resistor. We have a 3-part switch wired up, again through ground via the resistors, and then the data is being transferred to these 3 pins here. We have the rotary encoder, and we have the display. And these are all wired up very similarly to what we've done in previous days. And you can look at the circuit diagram in the course to see exactly how these are all wired up. But today, we're only going to be looking at the display. We're going to be looking at the program in a moment, but first I want to draw your attention to these bottom 4 lines in the program. And basically the whole point of this day's exercise is just to demonstrate some cool graphics on the display. And we've got 4 graphics set up. Again, we'll come to these when we get to the program in a moment. So at the moment you can see the display is displaying nothing because all these lines are commented out. Let's put back in the first one and download the program. And you can see now we have a smiley face on the display. Very cute. Let's comment that line out and put the next one in. And re-upload the program. And now we have some kind of silly face. Okay, let's move on to the third one. Comment out the second one. Upload the program, and the third graphic should look very familiar to you. It's the Inventor.io logo. It's pretty cool. And finally, let's look at the 4th graphic. Upload the program, and we have a smiley face Saturn. That's the purpose of today, is just to show some cool graphics. But let's take a look at the program. Here's the code, and remember that we'll be expanding upon this over the next 5 days. So we have our familiar include at the very top, bringing in the graphics library for the OLED display, and then we're defining a few pins. We have the 3 pins for the rotary encoder, and we have 3 pins defined for the dip switch, and a pin for the LED. And we initialize the display as before. The 4 graphics that we just saw are defined by breaking down each pixel into a series of hex values like this. So this is the smiley face. I think this is the Inventor.io logo. So you can see it's basically just a bitmap definition. And we're not going to go into how this all works, but here is a very handy site that they give you, convertio.co, which you can use to take your own images and convert them into this hex format, which is pretty cool. So you can play around displaying your own graphics on the OLED display. But as I said, let's gloss over how all these definitions of the graphics are made. The setup function is very, very simple. We're initializing the serial port as always. We're defining the switch to be 3 input pins, and we're defining the LED to be an output pin. In the loop, all we're doing for this day's lesson is calling the draw function. And the draw function we just looked at contains 4 lines to display each of the 4 graphics on a 128 by 64 grid. So that's really the whole of day 26, was just to demonstrate how we can do some cool graphics. Let's see how we're going to build on to this program in day 27. Let's go. So we're only going to look at the differences in the program from yesterday. We've brought in the library for the keypad. In this lesson, we're going to be looking at the keypad, the LED, and the 3 switch. So as you may recognize from previous days, we've got the information for the keypad. We're telling that it's 4 rows by 4 columns. We're defining which pins make up each row and column, and the character that each button is going to generate. Then we are instantiating the keypad. We're going to skip over all these bitmap graphics. The setup routine is exactly the same as before, except this time we have a new variable called display bitmap. You'll see in a moment how this changes, but it's initialized to 0. Now in the loop, as well as doing our rendering of the display, we're also going to be polling the keyboard to see what key we're pressing. And if we're pressing any key at all, it's going to illuminate the LED for 1 second. And it looks like this day's lesson is supposedly testing the keyboard and the switches ready for future days where we're going to be working on landing our spaceship. In the draw routine, depending upon that variable display bitmap, which can be 0 through 10, you can see that each case represents a different bitmap. Calculate face is the function that's going to be changing that display bitmap variable. So if we take a look at the calculate face function, you can see that it reads all 3 switches, and depending upon the combination of which switches are turned on, it sets that display bitmap variable to a value between 1 and 7. And if all the switches are off, it sets display bitmap to 0. So basically we're using the 3 switches as a binary value. So that's the program. Let's take a look at it in operation. So first let's test the keyboard. And for that, I've got the serial monitor up, and we can check that the keyboard is wired correctly by making sure the key that I press generates the correct character in the serial monitor. So 1, and you can see that the LED flashes on because it detects that we've pressed a key. 2, 3, 0, star, A, B, and so on. And we can check through all the key values and see that the LED goes on every time we press a key. Now let's turn our attention to the display. As you can see, it's displaying the graphic for all switches off. So if I turn switch 1 on, I get a different graphic. And if you were to look at the program, you would see that that is the correct graphic. If I turn switch 1 on, off, and switch 2 on, I get a yikes face. Switch 3 generates some graphic indicating that we need to decrease something. Switches 2 and 3 generate 3 check marks. If I turn all 3 switches on, I get some kind of meter from 0 to 100. I'm sure this will all make sense in the days to come. For example, I can turn switch 2 off, giving me a 1 and 3 on, and I get a check mark. And if I turn them all off, I go back to that default phase. So we could go through and check every combination of the switches and check that they display the corresponding bitmap graphics. So I think today was basically testing, and let's jump straight into the next day and see how we're going to develop this further. Since the circuit remains the same, let's dive straight into the program. And again, I'll just point out the differences. Everything at the top here about defining the pins and the keyboard is all the same, except now we have 2 new variables defined. One that's telling us if the correct key was pressed on the keyboard, and another that indicates that the switches have been correctly activated. And once again, this scenario is supposed to be setting us up for the landing sequence of our spaceship. So let's scroll on past all these bitmap images. The setup routine is exactly the same. The loop is just a little different. We've taken out the code that says the blue LED will light up anytime any key is pressed, and all the functionality now is in the draw routine. Now the draw routine is very similar to before in that it displays a different bitmap graphic on the OLED display depending on this variable display bitmap, except this time we have this new function, pilot keypad check. Pilot keypad check basically calls the calculate face routine that we used yesterday, and it looks at the return value from that. So first of all, let's just go into calculate face and see how that return value is calculated. Calculate face is almost identical to last time, except some of the bitmap definitions have changed for different values of the switches. So it still reads the 3 switches, and in most cases it just sets which graphic is going to be returned, except if all 3 switches are on, that's basically the indication that we're ready to land. It sets this switch activated 1, implying that all the switches are in the correct position, and in that case the function returns a 0. Otherwise, in all other cases, you can see it returns a -1. So let's go back to pilot keypad check. So right at the top here, it's saying if calculate face is less than 0 and the switch is not activated, then just exit this function too. And so of course, the first time we look at this, the switches will all be off, and so it'll just return and go no further. Now, if the switches were all in the correct position, it would go down further and it would look at the keyboard and see if we pressed the correct key, which apparently is key A to indicate landing sequence A. Now, if the key pressed is A, it sets the pressed variable. In other words, we've pressed the correct key, and it turns off the blue LED. Now, the next time through the loop, it'll come through, and of course, we won't be pressing the A key, but the was pressed variable will be 1 because we did press the correct key just now, and therefore it will set the LED to on, indicating that we're now in the correct landing sequence. We've set all switches and we've selected landing sequence A. Now, you're going to see 3 different bitmaps as we cycle the 3 switches, which is basically going to indicate a low power, mid power, and high power setting, which indicates our throttle setting. It's a pretty complicated program. I think they've kind of obfuscated this by adding in the graphics and the way they've done the state machine here with different switches and different magical values for the display map. There's definitely better ways you could code this, but for now let's go with what they have. I think it's confusing, but let's take a look at it in action. Here we are in the default status after just uploading the program to the hero board. If I set switch 1, it indicates that we're in a low throttle situation on the display. Now, incidentally, if I select a wrong switch, like switch 3, it gives me an error. Now, if I select switch 2, it indicates we're now in the mid throttle position. And if I select switch 3, we're now in a high throttle position. So now all switches are in the correct state. And now if we press the A key, we should enter the landing sequence. Now, if, for example, I press 2, nothing happens because that's not the correct key. If I press the A key, the landing light comes on and it gives us 3 check marks on the display to indicate we've entered the landing sequence. Now, you could play with those switches and get various bitmap error conditions if you cycle them in the wrong order. But that's about it for today. And I think tomorrow we'll be finishing up with the landing sequence. And then we'll be bringing in the rotary encoder and see how it all fits together. So see you in the next day. So apparently when we built this circuit a few days ago, there was actually an error in it. And they're correcting the error in today's lesson. So previously, the switch went to the digital pins and the rotary encoder went to the analog pins on the board. And they've decided to switch them over. I guess the rotary encoder needs the digital pins instead. There are a lot of changes to the program, and I'm not going to go through every single one of them. It would take me about half an hour, and I think you'd pretty quickly get bored. Basically, the exercise for today is we've left the planet that we crashed on, and we're now going to successfully land our spaceship back at base. So now we're going to see the full landing sequence in operation. This is the default setup. All the switches are off. We have the little face on the OLED display. And the first thing we're going to do is throttle up the engines. Switch 1 puts us into low throttle mode. Switch 2 puts us into mid throttle mode. And switch 3 puts us into high throttle mode. Now we're going to bring up the serial monitor, and just as before, we initiate the landing sequence by pressing the A key. We have the 3 check marks on the display, and now the rotary encoder is going to be representing our downward and upward velocity. So I'm going to start descending to the surface and keep an eye on the serial monitor and on the display, both of which will be giving us feedback. So as I descend, you can see my altitude, and it's telling me I need to continue decreasing because I'm nowhere near the surface yet. So I shall continue decreasing. If I decrease too fast, it thinks I'm going to crash, so it tells me to increase. So I will increase our velocity a little, increase our altitude a little, and now I shall continue descending. Descend a bit slower now. Keep descending. Still telling me to decrease my altitude. I'll keep descending. 14 meters. There's some kind of glitch still on this rotary encoder. And as you can see from the serial monitor that it keeps telling me I'm out of range and I have to restart back at 30 meters. It's kind of annoying. I don't know why it does that. I don't know if it's my wiring or my rotary encoder, or whether there's a bug in the program. Another interesting thing is I noticed we've wired up the switch on the rotary encoder, which apparently does nothing. So I'm just going to keep decreasing our altitude. It's actually telling me to increase, but I'm just going to continue decreasing. Not sure I entirely trust this program. And let's see what happens as I approach 0. And as I land on the surface, I get the little celebration face on the OLED, and the blue LED lights up to say we've successfully landed. And that's the entire landing sequence completed. Congratulations! You have worked your way through all 30 days. You were previously lost in space at the bottom of an ocean on an alien planet, and now you're back at home base. That's the end of the course. There is no lesson on day 30. And congratulations. Stay tuned for an upcoming video which will give you my full review of the kit. Don't miss that video. If you've really enjoyed this series, please give this video a like. I'll see you in the review video. Cheerio.